Okay, problem 14. So this one, a lot of you struggled a little bit knowing what formula to use. You know, we have that whole probability section on our formula sheet, and we have all these options. We have an AND formula for independence, and then we have a general multiplication formula, and then we have the OR and the conditional and all these things. My suggestion, when I work these, I write down the information that I have and then pick a formula that includes those pieces. So when I'm reading this, I'm going to make a list. It says, suppose 35% of students are enrolled in fine arts. So I'm going to write down the probability of fine arts is 0.35. 27% are enrolled in an ag class. So the probability of ag is 0.27. 43% are enrolled in fine arts or ag. So the probability of fine arts or ag, 0.43. How many are enrolled in both? So the probability of fine arts and ag. That's what I'm trying to find. So then if you look at your formula sheet, you need something that has the individual probabilities, the OR, and the AND in there. And I think it's at the very bottom of the first page. It says the probability of E or F equals the probability of E plus the probability of F, right now space, minus the probability of E and F. Please write down the formula you're using. It helps me a lot when I'm trying to give you partial credit if you made a mistake, so I can see where you are going with it. So the probability of E or F was 0.43. The probability of E, probability of fine arts, 0.35. Probability of F, the probability of ag, is 0.27. Minus the probability of E and F. That's what I don't know. So now we're just solving an equation. So I have 0.43 equals 0.62 minus the probability of E and F. So if I subtract over my 0.62, I get negative 0.19 equals the negative probability of E and F. Divide, so the probability of fine arts and ag is a 0.19. 19% chance that the student is enrolled in both. So writing things out will help a lot on those. Is that one okay? Problem 16. Everybody's favorite, these tables. So, part A. We want the probability that the driver is a male and over the age of 59. So, this is out of everybody. The first thing you have to do, since I didn't give you totals, you have to add up everybody in this table, and you should get 10,691 for the overall grand total. Then I want male and over 59. So you go to your males. Over 59 means they could be the 60 to 69, 70 to 79, or the 80 and over. Right? So what you have to do is add up those three numbers right there, and you should get 1,196. You get 0.1119. Part B. The driver is female or under the age of 30. So, the driver is female means you add up all of those. Okay, so that gives you 534. Can I write out the formula first? The probability of E or F, if you're using your formula sheet, is the probability of E plus the probability of F minus the probability of E and F. So the probability of E, probability of being a female, there were 5,354 females out of the 10,691 total. Probability of F. F is under the age of 30. So that means you can be any of those four things. So if I add those four together, I get 2,709. Minus the probability of E and F. So here's the problem. The females under 30, I counted those people twice. I counted them once in the female group and once in the under 30 group. So since they've been double counted, I need to subtract them off. So that is 1,336. So if you calculate that, you should get 0.6292. Is everyone okay? I know there were a lot of questions on that one yesterday. Okay, the other thing that we have really struggled with is the conditional. So please make sure you're paying attention to me here. C. The driver is 19 and under, given the driver is male. When you have a conditional, the first thing I want you to look at is the condition, the given. The driver is male. So that is my denominator. So all of my males, it's 5,337. Now, that is the only thing I'm looking at on my table. From those, I need 19 and under. So that would be 507. Divide those and you get 0.0950. D. The driver is female given the driver is between the ages of 20 and 49. So when I see that given, that's where I'm starting. Between 20 and 49. So you have to add up those 6 numbers, and that is your denominator, which comes out to be 5294. From that group, I want the driver is female. So now add up all the females out of those 6 numbers that I was looking at. We get 0.4979. So when you have a conditional, you start with the given in your denominator. E, the driver is between 20 and 49, given the driver is female. So this time my given is the female. So I'm only looking at my females, so my denominator is all females, 5354. My numerator, out of those, I want between 20 and 49. So that would be those 3 numbers there. Add them up. We get 0.4923. Any questions there? Problem 17. Okay, so this one is asking us to do a probability function. Part A is the table, including columns for x p of x and x squared p of x. So that means you have to make an x, you have to do a p of x, then I also said find x p of x, and x squared p of x. So the possible x's we have are 1 through 6. To find each probability, you are plugging those into the formula, which was x squared over 91. So you could do a decimal. I just kept them as a fraction. So 2 squared over 91 would be a 4 over 91. 3 squared is 9 over 91. 4 squared, 16. 5 squared, 25. 6 squared, 36. X, P of x, you're doing exactly what it says. You're going to take the x times the probability. So 1 times 1 over 91 is 1 over 91. 2 times 4 over 91 is 8 over 91. 3 times 9 is 27 over 91. 64 over 91. 125. And 216. Everybody with me so far? X squared P of x. So you take your x, you square it times the probability. So 1 squared times 1 over 91. 2 squared is 4 times this is 16 over 91. 3 squared is 9 times 9 over 91. 6 squared, or 4 squared is 16. So we get 256. 625 over 91. 1,296 over 91. Does everybody know how I got that table? And again, you could have done decimals, but the fractions were just easier, I thought. Okay, part B says find the mean. Look on your formula sheets for me. There is somewhere, talks about the expected value or the mean under chapter 6 of a discrete random variable. Tells you mu of x equals the sum of the x p of x. We have the x p of x's. So the sum, the mean, you just add all those up. So you add that column and you get 4.8462. Okay, you don't have to divide it by anything. The formula just says add it up. Okay, C and D are very closely related. I'm going to jump to D for a second because it asks for the standard deviation. And your formula sheet has standard deviation on it. Tells you it's the square root. It gives you two possibilities. And the easiest is probably to do the second one, the sum of the x squared p of x minus the mu squared. So if you add up all of your x squared p of x's, what do you get? 25 minus the mean that we just got squared. This, guys, please show work on this because if you missed your mean, you automatically miss the others. But if I can see your work and double check it, I'll only take off for the mean. Okay, so just show me work whenever you can. And this comes out to be 1.2306. Part C is the variance. How do you get variance? You square that. And you get 1.5143. Possibility of being slightly off for rounding error. But any questions there? Problem 18. Okay, so a doctor knows from experience that 12% of the patients to whom she gives a certain drug will have undesirable side effects. Find the probabilities that among 20 patients to whom she gives the drug, part A, at most 3 will have undesirable side effects. What kind of distribution is this? Binomial. Because there are two possible outcomes, yes or no. They have the side effects or they don't. We do have a binomial table as well as a formula for doing the binomial. My suggestion is use the table whenever you can, but remember it only went up to certain n values. So we have how many patients here? 20. So that actually is on our table. We could do this. We want the probability at most 3. So at most 3 means you could have anything less than or equal to that. So we could have 0, 1, 2, or 3. Okay, we have the 20 on our table, but we also have to have the probability across the top. P is the probability of success. Success in this case is the side effect, because that's what we're trying to calculate. Can I do a 12% on my table? No, so we have to do it by hand. But if I had said the probability of side effect was 15%, then you could use your table. So if you're looking on your other formula sheet, I don't know where I just set mine, but there is a formula for the binomial. It's under chapter 6. P of x equals, and it has this n choose x thing. So my n would be the 20. Choose, we have to find 0. P is the probability of success, which we're counting side effects. And that would be to the x power. 1 minus p, so 1 minus 0.12 is 0.88 to the n minus x. So basically this is saying nobody has it and 20 of them don't. Okay. Then we have to do the 1. So we do 20 choose 1, 0.12 to the first, so that means 0.88 to the 19th. Then we have to do the 2. So 20 choose 2, 0.12 squared, 0.88 to the 18th. And then we do the 3. 20 choose 3, 0.12 to the third, 0.88 to the 17th. These two exponents always add up to 20. Alright, you can do this on your calculator, remember? You start with the parenthesis. Do you guys remember how to get to the choose? If you go into math, it's there. So you have to do parenthesis, enter your 20, then hit math and go over to probability, and you'll see that NCR. So then you can do 22, 0, 0.12 to the 0, 0.88 to the 20th. And I like to just hit second enter and bring it back up and change my exponents. Is everybody getting this? So if we do that, you should get 0.7873. So binomial, use the table if you can. If not, use your formula. Remember, binomial is when you have a yes or no possibility. You have side effects or you don't. And then we have part B, excuse me. I'm going to skip that. Mean, variance, and standard deviation. So all of this stuff, you guys know, it's all on your formula sheet. Chapter 6, we're talking about the binomial. And it tells you exactly what to do, that second column there. So your mean is n times p. So n was 20. My p is 0.12. You get a 2.4. Variance is just the standard deviation squared. Formula sheet gives you the standard deviation, so you could find either one first. So if I'm finding my standard deviation, it's the square root of my n times my p times 1 minus p, which is 0.88. And that should give you 1.4533. Variance is the square of that. And you get 2.112. that one all right? Um, 26. Okay, so this says approximately 22.4% of the adults are smokers. A random sample of 300 is obtained. Describe the sampling distribution for p hat. So when I'm asking you to describe it, I'm asking you to find what? Mean, standard deviation. Okay, so my mean for p hat, if you've forgotten how to do it, look on your formula sheet. It tells you right here under the chapter 8. So the mean of your p hat is just p, which is 0.224. Standard deviation for p hat is the square root of p, so 0.224, 1 minus p, over n, and our n here was 300. So we get 0.0241. What are the requirements we should check? Less than 5% of the population, which is 300 less than 5%. Okay. You also need to check your n times p times 1 minus p greater than or equal to 10. And that works out as well. So check those requirements. Know those. Okay, part B wants to know the probability that at least 50. Okay, so that's like saying the probability that x is greater than or equal to 50. But we need to change that to a p hat. So p hat is x over n, so 50 over 300. Which is like 0.1667, 6 repeating, but so we need to find the probability that p hat is greater than or equal to 0.1667. And remember on these, you always change them to a z so that we could use the table. So that's probability z is bigger than, and you do your p hat minus your mu over your standard deviation. So we found those in part A. So we're finding the probability that z is bigger than negative 2.38. Remember, for z, if you look at your normal table, it tells you the probability that something is less than. So to find greater than, we have to do 1 minus something. You look up negative 2.38 on your normal table, and you get 0.0087. So if you do 1 minus, you get 0.9913. Part C, would it be unusual? What's the unusual requirement? Less than 5%. If 18% or less were smokers. So we're finding the probability that our proportion is less than 18. Okay, so we'll change that to a z. So you do your 0.18 minus your mean, 0.224, over your standard deviation, 0.0241. That's probability that z is less than negative 1.83. So less than, remember the table does give you everything less than, so we're just going to the table. Negative 1.83 is 0.0336. So is that unusual? Yes. It's less than 5%, so it's unusual. Okay. I'm almost out of time, so I'm stopping there. If we have any other Unit 4 questions, I know I didn't work as many of that, we can hit those tomorrow. We'll also do the Unit 5. And then if you have any other questions, look back over the study guide and see if there's anything you need extra practice over, so I can pull those we can look at that tomorrow if needed.
Oh.